Hello and welcome everyone in this new series of earthquake resistant design of buildings. So, in this course, we are going to learn basically upon the basic principles of earthquake resistant designs that is given in the IS course. So, we are going to understand the basic principles and importance of structural dynamics. Okay, because till now, what we have studied in civil engineering was more or less based on static loading. Static loading are those loading which do not change with time. But there are different types of loading which may change with respect to time, and such are the case of dynamic loading. And dynamic loading can be of wind load or earthquake load type. So we have studied about the wind load in design of steel structures also when we go for the design of towers, steel towers. So in this course we study the dynamic load of earthquake type. So before going to that, we will also understand some basics of structural dynamics. That is very important. And subsequently we will also see how earthquake as a dynamic load acts on the structure and how do structure respond to that loading. And then after this structural dynamics, we are going to understand free and forced vibrations. See, life is possible only by the vibrations. You are hearing my sounds because of vibration of air molecules which is happening nearby the region of our ears. And vibration is there in the atoms itself, and vibration is almost everywhere. We walk and we move in to and fro mass fashion our hands and legs. So life is possible by vibrations and their mechanism and response. So all this part comes into the uh, part of structural dynamics. Okay, then we are going to understand basics of seismology, that is the performance of structures under earthquakes. Okay, and then we are going to evaluate the data on earthquake hazard and determine the likely seismic risk in an area or region, and then apply a site specific earthquake code design spectrum. Okay, so if we divide our series of lectures in 5 units, so we are basically going to cover it in 5 units, and unit 1 deals about the single degree of freedom system. I hope you must have understood about the degree of freedom when we have discussed about the static and kinematic determinacy, indeterminacy, like that. So this degree of freedom is basically uh, kinematic indeterminacy, or the number of freedom that is given to the structure uh, in the either of the axes x, y or z. And there are two types of motion, translation and rotation. So all these degree of freedoms are considered, but in unit 1 we are going to consider only those systems which have a single degree of freedom. That means there is going to be equations of single variables. Okay, so we are going to formulate those equation of motions. Okay, and in case of free vibrations and forced vibrations, then in every vibration, vibration comes to stop because of damping. So what are the types of damping that we are also going to learn, and how to respond to those dynamic loadings. Okay, response of a single degree of freedom system. So this is our unit 1. Then is unit 2, and here we are going to do model analysis, and this we can also say that here we are going to deal with multi degree of freedom system, MDOF. Okay, this is the meaning of this MDOF. And again, this we are going to study under free vibrations and forced vibrations, that is going to be damped and undamped both. There also we have to formulate the equation of motions, and we evaluate different parameters of motion like frequency, time periods and modes with the help of eigenvalues and eigenvectors. Okay, the Unit 1 and Unit 2 can be basically said as a part of structural dynamics. Okay. See, structural dynamics is a big subject that can be discussed in a separate course also. But in graduation level, we just include these two chapters from structural dynamics. And just like we say na, in mechanical engineering, if you make a machine which do not move, that means your machine is not perfectly made or manufactured. So a machine should keep on moving, and there most of the load that is coming on the machine or due to the machine is going to be dynamic load. Whereas in case of civil engineering, if you make a structure that should not move, if the structure is moving, that means your structure is failed. Okay, so structure should be static and machine should be dynamic. Okay, so a major portion of civil engineering goes into the dealing with the static loading. Okay, but also we also deal with dynamic loadings, of course, and that is what we are going to study in this entire series of lectures. Okay, so the third unit deals with the seismology, as we have discussed. It's an introduction to earthquake engineering, and I hope you must have studied the basics of earthquake in the course of geology. And here also we are going to discuss all those parameters of earthquake, different kinds of waves propagations, and magnitude and intensity of earthquake, and then earthquake history and the entire seismicity of the country. Then in unit 4 we are going to see how the structure behaves and the soil behaves in the situation when earthquake is there. So it's a soil structure interaction basically, because the entire load that is going to come on the structure is transferred to the soil by foundation, and foundation is designed as per the earthquake. Okay, so performance of a structure under past earthquakes and lessons from past earthquakes and soil liquefactions, and then SSI effect, that is soil structure interaction. So this is also a very deep topic that we are going to cover in just a unit. And then the last unit is earthquake resistant design tips and procedures that are laid down in the Indian standard codes. And basically there are a few codes, out of which one is very important, 1893. IS 1893 part 1 deals with the provisions that we have to make as per the seismic code into a building which is going to be earthquake proof. See, no building can be earthquake proof, rather we can say earthquake resistant. Okay, the design is earthquake resistant. We can't make a building completely proof, earthquake proof, because if we design a building for an earthquake of say scale 6, so we can't be assured that earthquake is not going to exceed the value of scale 6. It may increase. Okay, so there we are going to see the concept of earthquake resistant design and few provisions from IS 1893, and response spectrum, what is the design spectrum, and then design of building elements, different reinforcement detailings in different elements like the columns and beams and the joints, everything we will discuss there. And those reinforcement detailing will be discussed mainly from the provisions which is given in IS 13920. Okay, so this is also another code which deals with the special reinforcement that has to be provided in earthquake resistant design. So this is all about the syllabus, and if you ask of the textbooks, I would recommend there are different kinds of textbook also, but structural dynamics as far as it is concerned, I am going to use the book S. Damodar Swami and Kavita. But this book is very easier to understand for all of you, and Agarwal and Srikhande can be also used in the unit 3, 4, 5 earthquake resistant design of structures. So basically I am going through this book, Damodar Swami SR and Kavita S. So this book is available in library, you can go through that, and we will discuss from unit 1 to unit 5 earthquake resistant design of structures. So basically I am going through this book, Damodar Swami SR and Kavita S. So this book is available in library, you can go through that, and we will discuss from unit 1 to unit 5 earthquake resistant design of structures. from the next video. So stay tuned and stay safe. Thank you.